Welcome friends to the fifth video in this series of SAP on Azure. In this video, we are going to talk about deep dive on virtual networks. We will talk about some networking concepts like TCP/IP, protocols, and so on and so forth. We will also talk about name resolution, which is DNS. We'll talk about Azure load balancer and different type of load balancers like Azure Traffic Manager and Azure Front Door. So we'll talk about layer 4 and layer 7 load balancers. And I'll tell you what exactly it means by layer 4 and layer 7. So without any further delay, let's get cracking. Now, in our previous videos, we have briefly talked about virtual networks, what exactly they are, how they look like, how we create a virtual network. Let's take a deep dive into this and let's see how it is different from a traditional network. So traditionally, you had a data center and you had to basically bring in all the cables, and in order to create a network, you had to plug those cables in and create a network out of it. Now, with Azure, it's simpler because you can do it with a few click of buttons, or you can run a code and you can create a virtual network. Now, there are various features of a virtual network. Primarily, virtual network is the fundamental building block of any networking in Azure. If you have any resource which is in Azure which you want to intercommunicate, you have to place it in a virtual network so that they can intercommunicate. Virtual network is primarily a private network. When you first create it, it does not have any communication to the outside world. It is also a secure connection to any other Azure resources. It also allows you to communicate your Azure resources back to on-premises. You can also filter what traffic gets into your virtual network. You can route traffic from your virtual network, and you can do different kind of integrations with other Azure PaaS services or SaaS services. The virtual network typically contains one or more subnets. What is a subnet? Subnet is a subnetwork. It is a network inside a network. The subnets make networking more efficient. Through subnetting, a network traffic can travel shorter distances without passing through unnecessary routers in their destination. So say you have 4 virtual machines, which are all application virtual machines. You can place them in one subnet in a virtual network. You can also create connections between virtual networks, and you can also connect your virtual network to your on-premises data center via different routes like express route or VPN. Now, virtual networks support certain protocols. Let's look at those. First protocol which we will look into is called Internet Protocol, also called IP. The Internet Protocol is the address system of Internet and has the core function of delivering network packets or delivering packets of information from source device to target devices. IP is the primary way in which network connection is made, and it establishes the basis of Internet. IP does not handle packet ordering or error checking. That is where TCP comes into picture. TCP, also known as Transmission Control Protocol, also called TCP/IP. The TCP/IP relationship is similar to sending someone with a message written on a puzzle through an email. The message is written down and the puzzle is broken into pieces. Each piece can travel through different postal routes, some of which may take longer than the others. When the puzzle pieces arrive after traveling their different paths, the pieces may be out of order. It makes sure that the pieces arrive at the destination address. The TCP can be thought of as a puzzle assembler on the other side who puts the pieces together in right order. It asks for missing pieces to be resent and lets the sender know the puzzle has been received. TCP maintains the connection between sender from before the first puzzle piece is sent to after the final piece is sent. Let's look at a different protocol, also called UDP. UDP is faster, but it's less reliable than TCP. Another common transport protocol. In a UDP communication, the two computers begin by establishing a connection via automated process called handshake. Once the handshake has been completed, one computer will actually start transferring data packets to another computer. Another commonly used protocol is ICMP, also called Internet Control Message Protocol. It's basically used in the network layer, and this is used by devices to diagnose network communication issues. ICMP is mainly used to determine whether or not data has reached its intended destination in a timely manner. Commonly, the ICMP protocol is used on network devices such as routers. ICMP is crucial for error reporting and testing, but it can also be used in distributed denial of service attacks. So DDoS attacks, ICMP is commonly used. You might find in Azure, a lot of places in Azure Virtual Networks, ICMP has been disabled. Now you can enable it only for troubleshooting purposes. Last protocol is also called GRE, Generic Route Encapsulation Protocol. Generic Routing Encapsulation Protocol is a protocol for encapsulating data packets that use one routing protocol inside the packets for another protocol. Encapsulating means it's wrapping one data packet within another data packet, like putting a box inside another box. GRE is one common way to set up a direct point-to-point connection across the network. For the purpose of simplifying connections between separate networks, it works on a variety of network layers. Let's look into and understand IP addressing. Now, what is IP addressing and how it works? Now, you have a virtual network. When you create a virtual network, you have to provide certain IP address range to it. What does that mean? So when we create a virtual network in Azure and we provide an IP address range, that IP address range is called CIDR. What does CIDR mean? CIDR is classless interdomain routing. It is used to represent the network and the number of IP addresses in the network. For an example, let us say we have this virtual network and it has 192.168.0.1/24. That's the CIDR. When you subdivide this particular CIDR into subnetworks, also subnets, it will look something like this. So you have two subnets, 192.168.0.0/28 and 192.168.0.16/28. You will be subdividing a lot of virtual networks when you are actually implementing a solution in Azure. So you should know how the IP addressing works or looks like. You can use some free tools. One of the tools which I normally use is called ipcalc. You can just go to Google and type ipcalc. So if you provide it a CIDR range, it will tell you how many subnets can be found out of it. Or you can specify the subnet mask and it will tell you the number of subnets, the exact IP ranges of the subnets as well. Now, if you want to have an outside communication to this virtual network, and I earlier told the virtual network is normally isolated. It doesn't communicate to the outside world. If you want the outside world to communicate to this virtual network, you need to provide something called as a public IP. Public IP addresses allow Azure resources to become accessible directly from the internet. A public IP address can be assigned to a load balancer, an external Azure VM, or an application gateway, and so on and so forth. So there are two types of IP addressing as of now in the world. One is IPv4 and other is IPv6. IPv4 is the old form of IP addressing, which had 32-bit addresses, which can only provide us 2 to the power 32 IP addresses, which is 4.29 billion. And we are coming to a state where we will be utilizing all the available IP addresses. So IANA has come up with a different sort of IP addressing scheme. It's called IPv6. IPv6 uses a 128-bit IP address, hence it can provide you 2 to the power 128 IP addresses, which is much larger number, which is like 1028 times larger than the IPv4. So when it comes to public IP addresses, there are two types of public IP addresses. One is basic SKU public IP address, and another is a standard standard SKU public IP address. Now there are some differences between them. Let's see those differences. Basic SKU provides dynamic and static allocation And standard SKU only allows you to statically allocate the IP address. So what does that mean? It means that you can change the IP address. The basic SKU IP address can change. And it will also allow you to keep the IP address static in basic SKU, while in standard, the public IP will always be constant. Now, if the public IP changes in some scenarios, it can be a problem, because say you have a web server and you have assigned a public IP to it, and for some reason you change the public IP address and you have not changed the DNS record, then your web server will fail. So in a production scenario, it is always better to go for a standard SKU, public IP address. Basic SKU can be assigned to any number of resources. Same with standard SKU. Basic SKU can be assigned to a specific zone, but there is no zone redundancy available for this, which means if you cannot have the basic SKU public IP address available in case the zone goes down. Standard SKU also can be assigned to a specific zone, but it supports zone redundancy. So if the zone goes down, still you will be able to access the public IP address because it is zone redundant. Basic SKU supports IPv6 allocation, while standard SKU only supports IPv4 allocation. Now let's understand name resolution, also commonly called DNS. What is name resolution and how does it work? So suppose Sally is working in the office and she types in a web address in her computer. Now normally a web page has a IP address assigned to it. Now we humans cannot remember numbers, but we can very well remember names. So that is why the DNS has come into picture. Now we can say www.google.com, but we cannot say the public IP address of Google. So what Sally does is she types in the web page name www.google.com. The computer will query its own DNS cache if the IP address of the web page is available there or not. The IP address is not available. The DNS provider of your home network is going to query your ISP resolver. Now say the ISP resolver doesn't know the IP address. What will it do? The resolver will send the query to root server. The root server itself doesn't know the IP address of the web page. So what it does is it knows where to direct the resolver for a particular domain. For example, you have said www.google.com. It knows where it needs to redirect queries for a .com domain. So then it will redirect the query to a top level domain server. Top level domain server will contain the top level domain information like .com, .org, etc. However, it will not know the IP address of the website. Hence, it will direct the resolver to an authoritative name server. The authoritative name server provides the IP address which is stored in the DNS cache for next time resolution, and then the information is sent back to Sally's web browser. Sally is now able to browse the web. Now, the whole process is called iterative DNS resolution. Now, Azure itself provides its own DNS service, which means it has its own DNS resolver. By default, when you create a virtual network, Azure provides a DNS resolver and it will help you resolve any DNS resolution requirements in Azure. This may not be enough in some scenarios, and we may need to create something called as a custom resolver. For example, you have virtual machines or you have on-premises machines and you want to resolve names between the virtual machines and on-premises machines. You will need a custom DNS resolver because all your on-premises machines information will be stored in the custom DNS solution. It may not be available in the publicly available DNS. So like it should be in a private DNS. Now let us understand accelerated networking a bit more. We have seen accelerated networking earlier, but let's see how it works. Now, when you do not have accelerated networking, what happens essentially is your virtual machines communicate via a data path. Now, the data path looks something like this. So there is a switch and there is a network card attached to your virtual machine. The network card communicates via Azure infrastructure or Azure hosting infrastructure to the virtual machine. So there you can see there is a lot of hops in between. So the virtual machine's NIC basically uses the switch to perform the communication. Now what happens in a accelerated networking is same virtual machines bypasses the data path and it directly communicates to the network card of the other virtual machine. This high performance path bypasses the host from the data path and it reduces latency, jitter, and CPU utilization. Now, this accelerated networking is supported on most of the general purposes VMs. Accelerated networking is supported on virtual machine instances with 4 or more virtual CPUs and compute optimized sizes with 2 or more vCPUs. Also, it is supported on instances which support hyperthreading. Now let us understand Azure load balancers. Before that, we want to cover a very important concept called OSI model. Now what is an OSI model? OSI model is a conceptual model developed by IANA to enable diverse communication systems to communicate using a standard protocols. There are different layers in an OSI model. Now as you can see in the image, the first layer is the physical layer. Second is the data link layer. Third layer is the network layer. Fourth layer is the transport layer. The fifth layer is the session layer. And the sixth layer is the presentation layer. The seventh layer is the application layer. Now, the physical layer basically means your physical devices, switches, routers. Data link layer defines the format of data on the network. The network layer decides which physical path the data will take. The transport layer transmits data using transmission protocols like TCP and UDP. The sixth layer, which is the session layer, maintains a connection and it's responsible for controlling the ports and the sessions. So when you create a connection to a web page, you're basically creating a session. When you're opening a browser, you're creating a session, you're connecting a session to Google, for example. So that is where the session layer comes into picture. The sixth layer is the presentation layer. Basically, this layer makes sure that the data which is being transmitted is in a usable format. The seventh layer is basically your human interaction layer. This is where the applications can access the network services. In order to remember this, we can use a simple formula, which is please do not tease sexy Pamela Anderson. P physical, D data link, N network layer, T transport layer, S session layer, P presentation layer, and A application layer. So now that out of the way, we understand the OSI model a bit. Let's understand the Azure load balancer. The first thing which you should know is Azure load balancer is a layer 4 device. What is layer 4? Layer 4 is the transport layer, which means Azure load balancer works on TCP and UDP protocols. So what does a load balancer actually do? The load balancer is used to distribute traffic to multiple virtual machines. It doesn't understand application-based traffic. It will not allow you to do SSL offloading and other pretty stuff which you can do on a web application, but it will allow you to transmit data between virtual machines. Load balancer has a backend pool, a set of VM, and a front end, which can be a private IP address or a public IP address. There are certain rules which are used by the load balancer, like NAT rules, load balancing rules, HA ports, and outbound rules. And then there are health probes, which basically check, the load balancer makes a check on its backend pool if everything is fine or not. And as we saw, the traffic can come in from different sources like private or internet traffic. There are two types of SKUs available in the load balancer, and they basically depend on which scenario you are looking for. The first is a standard load balancer, and then the second is basic load balancer. So standard load balancer can be used within and across the regions. It is not compatible, and the basic load balancer is not compatible with AV zones. It's only AV set. Standard load balancer supports TCP and UDP, same with basic load balancer. Standard load balancer health probes can be TCP, HTTP, and HTTPS, while basic load balancer does not support HTTPS. The front-end IP of a standard load balancer can be a public standard IP, while a basic load balancer can only have a basic public IP. Diagnostics of Azure Monitor can be applied on a standard load balancer, while it is not available or not supported on a basic load balancer. HA ports are available for internal load balancer, while in basic load balancer, HA ports are not available. Now there is an SLA on the standard load balancer, like it has a 99.99% SLA. Well, a basic load balancer has no SLA. Standard load balancer supports global tier for public load balancers, but the same is not supported in a basic load balancer. Let's understand a bit more about the various components of the load balancer. The front-end IP configuration of a load balancer is the point of contact for all the clients who are coming in to access the backend pool of the load balancer. It can be either a public IP address or a private IP address. The front-end IP determines if it is a public IP load balancer or a private IP load balancer. The backend pool is a group of virtual machines which will be serving the incoming requests. Now, the load balancer needs to know if the backend pool is healthy or not. So what it does is it sends a probe back to the backend pool and checks, and if the probe comes back with a 200 OK command, which means that the backend pool is healthy, and it sends the traffic to the backend pool. If it gets no response, it will not send the traffic. In a health probe, you can define the number of unhealthy thresholds, and this probing doesn't affect the existing communication. There are different types of health probes available: the TCP, HTTP, and HTTPS, as we saw in the previous slide. Now, the next important component is the load balancing rules. Now, the load balancing rules work on a 5-tuple rule connection. What are these 5 tuples? The first tuple is source IP address. Second is the source port. Third is the destination IP address. Fourth is the destination port. And the fifth tuple is protocol. So based on these 5 tuples, you can define a load balancing rule. And you can tell from which IP address, which port the traffic is going to come in, and where the traffic needs to go in the backend, the destination IP address and the destination port. And you can also define which protocol needs to come in, like a TCP, UDP, and so on. There's also something called as an HA port. Now, what is this HA port? It's called high availability port. Now, a high availability port will allow all kind of traffic, like it may be TCP, UDP, any protocol. Why this is used, or where is it required? This is required in case you have a network virtual appliance, say a Palo Alto. Now, the next important configuration is the inbound NAT rule. So what inbound NAT rule will do is it will allow you to divert traffic to a particular virtual machine. It will forward the incoming traffic to one specific virtual machine instance in the backend. Now, you may use this kind of setting if you say you have one virtual machine in the backend and you do not want to expose the actual IP address of that virtual machine. You can use a load balancer as a NAT device, and in the backend you can have that virtual machine and you can have a connection coming into the load balancer, which in turn is going to use an inbound NAT rule and divert the traffic to that particular virtual machine. Now, this is not really a load balancing, but this is a NAT, also network address translation. The other kind of configuration is outbound rules. Now, normally when you have the traffic incoming to the load balancer, the outgoing traffic does not go via the load balancer. It directly goes to the required service. But you can configure outbound NAT rules for virtual machines, which will enable you to send the traffic via the load balancer. Now, outbound rules allow you to define a source network address translation, also called SNAT, for standard SKUs. These kind of SNAT rules or outbound rules are only supported in the standard load balancer and will allow you to basically divert your virtual machine traffic via the load balancer. There's some use cases of load balancer in the SAP environment. You may use a load balancer in front of your database nodes, wherein you have two databases, two or more database instances, and you have load balancer in front of them so that you can send traffic to one database, and in case that database goes down, you send the traffic to the other database. You can also use this load balancer for high availability configurations. Certain virtual machines which need to be highly available, you can use this kind of a load balancer. Okay, let's have a quick demo about load balancer. And we will be creating a load balancer in front of two virtual machines. So what I have done is I have deployed two virtual machines already, and one of the virtual machines has a public IP address. In order to perform the demo, I have logged in to one of the virtual machines. So let me connect to the virtual machine. Let me put in the password. Now, after logging into the virtual machine, what I have already done is I have installed a role called IaaS. I'll tell you where to do it. Now, once you log into the virtual machine, you can go to the server manager. In the server manager, you can click on add roles and features. You can go to next, 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 and in server roles, you can select web server IaaS and then click next and install, and it will install the IaaS role on the server. So IaaS is Internet Information Server. Basically, this makes your server a web server. Now, after doing that, I went to the PC, C drive, inetpub folder, www-root, and I have modified the IaaS start page. So what that essentially does is it tells you that this particular VM is VM01. So I'll show you a demo. If I say localhost, it should load an IaaS page which says I am demo VM01. Now let us try to connect to the next VM. The next VM, demo VM02, does not have a public IP address. However, it is in the same subnet as this VM. So I can connect with the private IP address. The private IP address of that VM is 10.0.0.5. I'll connect to it. I'm going to do the same thing here. I'm going to install the IaaS role, and I'm going to go to the File Explorer, this PC, inetpub, www-root, and I am going to modify the IaaS start page, which I have already done. So I will show you what I have done in this VM. So I have named this page I am demo VM02. The reason we have done this is that we are going to place these two VMs behind the load balancer, and then we are going to test if the load balancing is actually working or not. Now let's get back to our Azure portal. We will create a load balancer. Let's click on create. So the first thing which it asks is the resource group, which we have already provided, the name of the load balancer. So just let's name it AZ Lab LB01. The region is correct. We are going to select standard SKU. The type of load balancer should be public, since we are going to try to access this publicly. The tier is regional. Next, we need to select the front-end IP configuration. So we will click on add, and let's name this AZLB front-end IP config. IP version is IPv4. IP type, IP address. We can select an available public IP address. We have to create a new public IP address for this because we want to publicly access this particular load balancer. So let us select, and I have already created a public IP. Let's select that. We are not going to select gateway load balancer. Let's click on save. Next, we need to add the backend pool. So what is the backend pool? The backend pool is going to be our two servers which we have created. Let's give it a name, AZLB backend pool 01. We'll select the virtual network and it's going to find the two NICs available in this virtual network, demo VM01 and demo VM02. Let's select these two, click on add, and you also need to keep in mind that we have to keep these VMs in an availability set, in the same availability set for the load balancing to happen, either in availability set or you can put it in availability zone as well. Let's click on save. Next are the inbound rules. So basically the load balancing rules. This is very important. So we are going to name this AZLB LB rules 01. IP version is IPv6. Front-end IP address we have already selected. Let's select that. Backend is the backend pool which we are going to create. Protocol will be TCP/IP. Port you have to give 80, as well as the backend port should be 80 because the internet servers work on the port 80. Health probe, we will create a new health probe. This will be required for the load balancer to check the backend pool if everything is working fine or not. So let's name this AZLBHP01. Protocol will be TCP, port will be 80, and interval in seconds is 5, which means on TCP protocol on port 80, every 5 seconds the load balancer is going to send a probe and check if everything is fine or not for the backend pool. If it finds any one of the servers is down, it's going to redirect the traffic to the other server. So let's click on save, and we don't need to enable any other setting. We can click on save. Next, on the outbound rules, we do not want to have any outbound rule at the moment. Next, and create. The validation has passed. Let's click on create. So our deployment is done now. We can go back to our load balancer. Let's check all the settings are applied correctly. Front-end IP configuration, we have a public IP address. Let's copy this public IP address. The backend pool should contain the two VMs which we have created. So it has demo VM01 and 02, and both are running. The health probe which we had created on TCP protocol port 80, interval 5 seconds is up, and the load balancing rule, which is basically going to send the traffic back to the load balance to the backend pool on port 80, and the protocol is TCP protocol. Everything looks fine. Let's try to browse using the public IP address of load balancer, and you can see a page comes up. It says I am demo VM01, which means we are connected to VM1 right now. Let's go ahead and switch off the VM1, and let's see if the load balancer will automatically redirect the traffic to VM02. Let's now try to connect to the load balancer again. Let's paste the IP address, and you can see it is connected to demo VM02, which means the load balancer is working and it is sending the traffic to VM02 now. We can start the VM. Let's switch off demo VM02 now, and let's refresh this page. It's connected to demo VM01. So you can see the load balancing is working properly, and the traffic is redistributed between VM01 and VM02. Now let's look into Azure Traffic Manager. Now Azure Traffic Manager is a DNS based load balancing solution, and it can be used over, you can use different regions. You can load balance your traffic over different regions. This will allow you to distribute your traffic across the globe. Now, for example, in this particular example, A user requests for a website, a browser, and the browser is going to the DNS resolver. It's going to perform a query on the DNS resolver. The DNS resolver is going to send the traffic to Azure Traffic Manager and ask for the web page address of that particular website. The Azure Traffic Manager is going to check all the regions which are there, which is for example, there are 3 regions: primary region 1, 2, and 3. Now, if, for example, one of the regions is down, the Azure Traffic Manager is going to send a response back that the current available region is primary region 2 to the recursive DNS query. And this information is then sent back to the browser. The user will then directly connect to the primary region 2. So this is how an Azure Traffic Manager works. Let's look at another interesting concept called Azure Front Door. Now, ATM can be a good option if you are looking for DNS based resolution, but then you have to think about time to live of DNS records. Like it doesn't understand cookie based affinity and SSL affinity. Hence, we can use a global load balancing solution like Azure Front Door. Now, what is Azure Front Door? Azure Front Door is a secure CDN, and it delivers content files, basically all APIs, and it works on the layer 7. Azure Front Door uses Anycast protocol with a split TCP and Microsoft's global network for improving global connectivity. It integrates security with content delivery network and provides fast, reliable, and secure access between users and applications, and static or dynamic web content across the globe. It uses Microsoft's Global Edge network, which Microsoft has set up with 4,000 internet partners and thousands of connections in more than 175 locations. So how does Azure Front Door work? Azure Front Door is used as the first entry point. Now, from the AFD, a user is routed to the most appropriate location based on the latency and the health of that region. The request then goes through a web application firewall, also known as WAF, which is fully managed Azure networking service, and then it goes to required endpoint. You can see in this example, the traffic is diverted to different regions like East US, North Europe, or Australia East based on the user's location. User may be located in East US, traffic will be diverted to East US. If the user is in North Europe, the traffic will go to North Europe, and similarly to East Australia in case he is located in East Australia. Good. Now let us look at some of the questions which you might encounter when you go for an examination. The first question is, you plan to deploy SAP landscape on Azure. The landscape will use SAP HANA database that run on Azure virtual machines. The landscape will have 4 Azure virtual machines which will have SAP Web Dispatcher role. You need to minimize the network latency between the Web Dispatcher virtual machine and the HANA virtual machine. What should you use? Well, you should enable accelerated networking. Now, this can significantly reduce the network latency between virtual machines and enhance the network performance. The second question, you have an Azure subscription. You deploy Azure Active Directory domain controllers on the Azure virtual machines. You plan to deploy Azure SAP workloads. You plan to segregate the domain controller from the SAP systems by using different virtual networks. You need to recommend a solution to connect virtual networks, and this solution should also minimize costs. So we can use simple virtual network peering. Virtual network peering will allow you to connect different virtual machines seamlessly across virtual network. Virtual network peering is cost-effective and efficient solution for connecting networks within the same region. Third question, you have an Azure subscription and you plan to deploy SAP landscape. You need to configure an NFS cluster that will host the storage of the landscape. The solution must ensure that the cluster is available if the Azure data center fails. How should you configure the cluster? For the following components: for virtual machine resiliency, for network resiliency, and disk type. For virtual machine resiliency, deploy to AV zone. For network resiliency, Azure standard load balancer. For disk type, you can use managed premium disks. Well, friends, thanks for watching this video. This was a bit long one. However, we covered a lot of concepts in this video. I would love to see you in my next video. And if you find my content useful, please consider sharing, commenting, and subscribing on my channel. It'll help me motivate and create more such videos. Thank you. I'll see you in the next one.